Okay, quick question. Two friends both scored an average of 70 on their last 5 tests. Same average. So they are the same, right? Wrong. One of them scored 68, 70, 71, 69 and 72. Basically the same every time. Super consistent. The other scored 40, 90, 50, 100 and 70. All over the place. The average tells you where the center is, but it says absolutely nothing about how spread out the data is. And that's where the real story lives. Today we are talking about 3 tools that measure exactly that: range, variance, and standard deviation. No scary math, I promise, just the idea behind each one. Let's start with the simplest one, range. Range is just the gap between the highest and lowest values in your data. That's it. Take friend B's scores: 40, 50, 70, 90, 100. The highest is 100, the lowest is 40. The range is 60. Friend A, highest was 72, lowest was 68. Range is just 4. Bigger range means more spread out. Smaller range means more consistent. Simple. But here's the catch. Range only looks at 2 numbers, the very top and the very bottom. It completely ignores everything in between. The range looks massive even if every other data point was actually normal. So we need something smarter, something that uses all the data, not just 2 extremes. That's where the variance comes in. Here's the idea. What if we measured how far each data point is from the average? Say the average is 70. A score of 90 is 20 points away, and a score of 50 is also 20 points away, just in the other direction. So we just added those differences up, the positives and negatives which cancel out, and we'd get 0, not helpful. So instead, we square each difference, multiply it by itself to make everything positive. Then we average all those squared differences. That average is the variance. But there's one awkward thing, because we squared everything. The units get weird. If scores are in points, variance is in points squared, which nobody actually says out loud. So we take one more step. We take the square root of the variance, and that gives us the standard deviation. Standard deviation is basically variance, but in normal units again. Back to points, dollars, centimeters, whatever you are measuring. This is the one you will see everywhere in news articles, science papers, finance, sports stats. For friend A, the standard deviation might be around 1.5 points. For friend B, it might be around 22 points. The difference tells you everything. Friend A is reliable, friend B is unpredictable. Same average, completely different story. Quick recap. Range is the gap between your highest and lowest value, fast and easy. But one outlier can throw it off. Variance measures the average of all the squared distances from the mean, uses all the data, but units get awkward. Standard deviation is the square root of variance, brings it back to the normal units, and tells you the typical distance any point says from the average. Small standard deviation means a tight cluster. Large standard deviation means wide scatter. These 3 measures all are answering the same question: how spread out is this data? And once you get that, you start seeing it everywhere. Test scores, salaries, weather, investment risks. The average tells you what's normal. The spread tells you how normal actually is. If this clicked for you, hit like. It genuinely helps. And subscribe if you want more of this kind of things. I've got more stats concept coming that I promise that I won't make your head hurt. See you in the next one.